Good morning and afternoon, everyone. Welcome to this week's Autodesk HSM Weekly Fast Track Hangout. I'm Wayne Griffenberg, an AE at Autodesk, and today we're going to walk through setting up some simple vise assembly that we're going to download and upload into Fusion, make a simple part, and then create some soft jaws from it. So what's driving this subject? We're going to jump right into it. We have a lot to cover, so I'm going to get right into the details of today's webinar. So before we do that, I want to make sure that you guys know that we have until June 16th to vote for your classes that you want to see at Autodesk University. So if you guys have specific classes, I know a lot of our elite users and our power users out there have created classes or at least made some proposals for classes. I highly suggest go out there and vote for those classes that you'd like to attend this year at Autodesk University. We've done a lot of webinars this past year, and it started with one that CJ did to follow up from that video that CJ made on Don't Fear 5-Axis. A lot of the webinars started with CJ just doing a QA session and answering some of the questions that people had, how to set up the part, how did he get some of the toolpaths working, and he also joined us later on with some other webinars and showed us different ways for doing work holding. Here's some his last presentation he did with us, and it's a pretty cool assembly that he did of that DMS machine at Pier 9. And if you haven't followed him on Instagram, I highly recommend going and see some of the projects he's worked on. Some pretty amazing setup that he's done on some of the parts. And this is just scratching the surface. So CJ did an awesome job with us on our presentation, but that was one of the themes was how did he do a lot of those setups? What were some of the questions on the soft jaws? How did he set up that part? We also had Tim Paul, amazing machinist. He set up a lot of parts in Fusion and runs them. He joined us in a couple of our webinars as well to walk through how he sets up some parts. He did that, the Metsura belt buckle, which is amazing. I still want to get one of those. And he had that set up on that Metsura machine, as well as the bottle opener. I do have one of these still, and I use it all the time. But he did a great job setting that up. Did some soft jaws, had this in a live demo, and was able to do it at demo days. If you check out his Instagram channel as well, and you'll see a lot of those setups that he does every day, and check out some of his work there. It's just amazing. Another part of these webinars, and the questions are, how do you work with some of those models? And a lot of people have asked for some of those models to work with. We had Angelo Juras join us in one of our webinars specifically to talk about setups and work holding. And he was talking about some soft jaws. He went through different ways that he did different setups to save time, being able to make them much more efficient. Parts like this, you know, how would you make something like that? And showed he simply did it with just a very few setups, used some tabs, and was able to do an amazing job to set it up. Other parts that he worked on, which looked like it would be like a pressed part, but he's able to machine it using specific setups that he worked on in the machine. And again, if you check out his YouTube channel, his YouTube channel, yes, and also check out his Instagram channel, and you'll see a lot of the setups that he does daily as well. So I'm kind of just going through some of the webinars we've had in the past where they were really focused on work holding and setup and machine setup. John Saunders joined us and walked us through and gave us some amazing points on what to look for if you're new to CNC machining or if you have a new machine, things to look for setting up your parts. We've had Lawrence Winshank joined us too and was able to walk through some of those setups that he uses on his machine. Rob Lockwood joined us to talk about some of the setups that he's used in the past. Seth Medor, Joe Eisel from HFO NIMAT was able to join us and talked about how he set up those machines for Haas demo days. Just a few weeks ago, Sunny McCullough was with us and talked about some of her curriculum and what she did to set up a custom handle for a vise, as well as in her curriculum how she teaches her students to make those soft jaws before they move on to the next section in her class. So these are just a few that we've done, but a lot of them that talk about work holding, tips and tricks that come from these experts and people who do it every day, power users and the Jedi Knights of working with Fusion and working with CAM. and to be able to get CNC set up in a really good way. So one guy I want to mention too, Matt, another Jedi Knight when it comes to CAD and CAM, and he's also a really good programmer, created a series of post-processor developing for you guys to be able to follow. The behind the scenes here, if you look at his Instagram account, you'll see that he's setting up machines all the time and does a really good job of getting really efficient toolpaths, setting them up, working with some really nice horizontal machine setups, and he did some really cool stuff. So check out his Instagram page too. That's Matt Nichols. Matt's going to be here next Friday. So join us next Friday. He's going to walk through how he programmed a part for the Haas UMC 750 to run on demo days. So that's next week. Matt Nichols is going to join us. So getting into working with some of the vise assemblies and soft jaws, we're going to do a really simple part, and they're going to download a vise, upload it into Fusion, and show you how to bring your part in to make those soft jaws. As I had mentioned some of those other webinars that we've done in the past, a lot of questions and a lot of new users have asked if they can download some of the vices that we work with, and if they can also have a step-by-step walkthrough on how to set up their vices and their fixtures according to the way it is in their machine. And I just want to mention, a few weeks ago, Lars Christensen, each week he puts out his Lars Live episodes on helping people set up their machines, learning about toolpaths, what's new in Fusion CAM, and what's new in HSM. And he's got a lot of videos for you to check out, and I highly recommend visiting his website on YouTube, his YouTube channel, and there's one in particular in the center there where he shows you how to put a part in a vise, step by step. Really good interface to learn. I highly recommend going to Lars's website and take a look at some of these videos. Check out his YouTube channel as well. I keep saying YouTube. Check out his Instagram channel as well, because he updates it almost daily with some great tips and tricks on how to hold your parts, how to run those toolpaths, how to set up working on the Haas. Some really great tips on positioning and being able to get the toolpath efficiently to cut the parts you're looking for. So I highly recommend checking out his Instagram channel as well. So a couple weeks ago we had Kurt Chan join us too, and we're talking about that Instagram community. We have some great users out there that show us daily what they're making and some of the amazing setups that they do. And we had Kurt on with Phil Butterworth, and Phil walked us through some amazing setups that he's worked on as well. Before we get into that, I want to talk about the Instagram challenge that Kurt, as he's connecting with that community in Instagram, he's also started the Fusion Cam Challenge this year, and it was all about work holding. And I'd like to congratulate Makers Inc. For this amazing work holding submission that you did, which won. Really awesome way to set up a part, completely designed in Fusion, all the way through, design documented, all the way through to making the physical part. Congratulations, Makers Inc. Got an orange vise as well as the Carve Smart package and a free ticket to AU. And runner-up was Phil Butterworth, who was also on this webinar with Kurt, and he did an amazing swing arm assembly, completely done in Fusion, all the way from the concept to design to being able to make the actual part. Really awesome job. The third place was Regal Metalworks, and they made this custom exhaust for a Porsche. Amazing job in producing parts. And the fourth was our Innovation Forge. They made some amazing woodworking fixtures as well. Okay, so Phil Butterworth was part of that webinar with Kurt. Innovative ways that he set up these parts to be made. Showed us some interesting ways to avoid collisions and being able to get into some interesting places on the parts. Really nicely done. Giving us a lot of background on the way he'd set up some parts using the dovetail on this one, being able to get at all those different nooks and crannies of that part, if you will, with one setup. And also some other custom setups to set up those parts. So I'd like to get started now, but I know there was a lot of new users who had asked how to set them up. So I'm going to take a Chick vise. I'm going to download a Chick vise. I'm going to upload it into Fusion. And when we get into Fusion, I'm going to turn it into an assembly where you can move the jaws back and forth. And then I'm going to design up a simple part. Well, this is actually a sprocket with a hub. We're mainly going to do the hub part. And I just want to model it up really quick to show you how you can work with pockets using parameters to be able to change them. And then we're going to bring that part into the vise and set up some soft jaws and just walk through those steps, and hopefully this will be helpful for you. I know there's a lot of users who are still working on learning these steps. So as we go through, please feel free to ask questions. I know Matt Nichols is on with me. He can help to answer some of them, and I'll do my best to answer them as well. So I'm going to get started, and I'm going to bring up my Fusion, and I'm going to bring up my web browser. I'm using Google Chrome, and I'm just going to go in to grab a Chick vise. So I'm going to go in to look for my Chick vise. Looks like I searched there earlier when I was practicing. So I'm just going to go into this Chick Work Holding Solutions page and go into download a Chick. Now you do have to sign in. I'm already signed in, but you create an account so that you can be able to download the different vices. You can download Curt vices, the Mighty Bytes. You can also get 5th Axis vices as well, and work holding fixtures. So I'm going to just walk through the Chick one today, and today I'm going to look for a product. I'm going to get the Quick Lock, and I'm going to use this 1540 today. All I'm going to go in and select the 1540, and it enables me to download some files. I like to work with IGES or STEP. Today I'm going to work with STEP. It seems to work the best when I bring it into Fusion to make an assembly. So I'm going to download the STEP file. It takes just a second. And I'm going to take a look at that, and it downloaded into my downloads folder right here. So it downloaded the STEP file for me to upload into Fusion. So I'm going to go back into Fusion. I'm going to go into a product that we're working at today. I'm going to work in this Fusion or this Fast Track to CNC Programming folder. So I'm going to go into this project. There we go. So I'm going to upload it into this project. So I'm going to click Upload. I'm going to select the file. Now, some of you may not know, but there's a lot of different files you can upload into Fusion. Native files, you can do native SolidWorks files, STEP files, STLs, Rhino files, native, Pro-E files, Parasolids, different binary files, IGES, CATIA native files, as well as Inventor files. So there's a lot of different files we can upload, especially native files. And just to let you know, if you upload it into Fusion, you can also keep that original native file, and if any changes happen to it, you can upload those changes into Fusion. It'll upload into your design as well. So in this case, I'm going to open this STEP file. I'm going to open it, and I'm going to say upload. And in the background, in the cloud, it's going to upload that file and translate it into a Fusion F3D file that we can work with. So as that uploads, I can close this out, and I can see the progress down here in the corner here. So it looks like it uploaded. It's finishing the progress that we did. So pretty quickly, I'm able to get a file in here, a version 1. It's now a Fusion file. So I'm going to open that up. Just going to right click and open it up into Fusion. Okay, so there's our Chick vise. It looks like it's in a different position than what I'd like it. So I'd like to rotate it around. I want to have it in position as if it's in my machine. So right now it brought in all these files. Now STEP files work pretty well in bringing in each of the components with its own origin and body. And that's pretty good. Sometimes you'll open up different files, even SolidWorks files or Pro-E files, and they just become as just standard bodies that make up the whole. And we can also work with that as well. But today it looks like we're able to get the STL, or I'm sorry, the STEP file brings us different bodies that we can work with. But I'm going to move them all at the same time. So I'm going to select some of these bodies. I'm going to move them. I'm going to hold Shift, and I'm going to grab the bottom one here in my browser. What I'd like to do is I want to rotate this around so that its X, its Y, and Z match the way it's set up in my machine. So as I have it highlighted, I'm going to right-click on any of these files, and I'm going to say Move or Copy. So I have these handles where I can rotate the handles, or I can move it back and forth, or I can grab the origin and free move it. So I'm in the free move mode. What I want to do is I want to grab this handle and flip it down this way, 90 degrees, so now it matches the way it's sitting in the machine in the Y and the X and Z. So my X is going along this plane, my Y is going up here, and my Z is straight up. I'm going to say OK. Now one thing I noticed too, if I turn on the origin, it looks like the origin is on the bottom of the part, somewhere on the inside. What I'd like to do is I want to get that origin to be at the very top of this plate right here. This is the fixed jaw plate. So I can move the part from the fixed jaw plate down. Now, one thing I have to do, actually let me change this over from millimeters to inches because today we're working on inches, so I don't forget. So I'd like to move that, but right now I don't have any features on this top of this jaw. What I can do is normally I would like to have like a dowel pin hole where I can come in and probe off and find that center and call that my G54. In this case, I don't really have anything there. I don't really have to draw anything. All I have to do is create a sketch on that face. Okay, I didn't do a create, so I'm going to right click, create a sketch on that face, but I don't have to add anything. I'm just going to stop sketch. Just a little bit of a tip. Because I created a sketch and it found the boundary of the part where I'm making the sketch, it also put a center on here somewhere, or it's making a liar out of me, but often you'll be able to find a center on that sketch. If not, I can also add a line going across to put a center on that sketch. Let's do that. So I'm going to edit that sketch real quick, and I'm just going to simply draw a line from the center here down to here, and then we'll be able to have a midpoint of that line to be able to hook to. Sometimes you can also do this. You can sketch, and then you can put in a simple point right in the center. Now we can use that point to be able to move this vise. Now that's just one quick way. Sometimes I'll actually make a hole there, but sometimes you just have to put a sketch so you can move this around. Later on when we move it, we can get rid of that sketch too. So I want to move this part. I want to move it to that center point right there. So I'm going to grab all the bodies underneath it here, again holding shift, right click, go back into move, and this time I'm going to change it to move point to point. And where do I want to move? I want to move this point to the origin. Now I can't quite grab the origin underneath of there. Sometimes it's a little bit hard. You can use a shift key. I'm going to expand down the origin and just simply click it here, and it moves it down to the origin. So you can actually grab the planes, or you can grab the axes or the origin right in the browser window. So it moved it down. Okay, I don't really need that sketch anymore because now I'm going to be fixed in that position. So now what I'm going to do is I'm going to get rid of that sketch. Right click and just delete that sketch out. I don't need it anymore. Okay, so now what I want to do is I want to fix these components that are supposed to be fixed, the ones that don't move. So I'm going to select those, holding Control. I'm going to select those components out of a list here on my browser. So I'm going to grab that plate, and down here, that's the fixed jaw. This is my moving jaw, my other moving jaw, and then I have these other fixtures of the labels as well. So those are the components that I don't want to move. I want to be able to move these moving jaws right here. So as I have those highlighted, I'm going to right click, and I'm just going to say ground. So now I have this push pin in all of those components. So now I grounded them, so now I'm free to be able to move these components, but I can't move those parts that are grounded. Okay, so I want these to move and slide as if they're on the actual jaw. So now what I want to do is I want to create some joints. So I'm going to go up to Assemble. I'm going to choose Joint. Now joints, they are going to limit the axis of free movement, but they're also going to mimic the way things work in the real world. So I want to make a sliding face, a face-to-face slider joint between the center of this jaw and the center of my fixed jaw. So now when it goes into place, it makes a rigid joint. You saw it moving back and forth like it's going to lock it there. I'm just going to change that to become a slider joint. Now if it was sliding in the wrong direction, I can easily change the axis of movement. So it says Z-axis because it's looking at it along the center. So there's a sliding joint on that side. I'm going to say OK. I want to repeat that same joint. I don't have to go up. I just right click, and I can go up and pick repeat joint. I'm going to select this center, and now it gives me that same sliding joint on the other side. Now you notice I'm able to slide them, but it also goes all the way through the model. So one way you can do is limit that. Now I know there's a lot of people who like to put in the actual screw movement. You can do that. You can do the assembly with a joint. You can also do it with a drive and motion link or drive joint. I'm just going to do a simple a joint limit. So if I expand down, you notice we now have this joints folder right here. So if I expand down, I can see my two slider joints. I'm going to right click on this slider joint, and I can go down to Edit Joint Limits. So now I can limit it as a minimum or a maximum. So if my minimum was 0, my maximum, let's say I want to make it 3 inches, Okay, and it locks it out 3 inches. So now I can slide this. When I slide it in, it goes to 0 and it goes out to 3 inches. So now I can lock it there in between 3 inches and 0. I could do the same thing on the other slider joint as well. So I'm going to say my minimum 0 and my maximum will be 3 inches. Now I often like to lock it. If I know ahead of time how wide I want to make this, I'm going to put a block in here, and that's where I'm going to start my soft jaw. If I'm going to keep that 3 inches wide, I'm going to have a block. I'm going to lock that down. I would just simply make it my minimum and maximum will be 3 inches. And now it won't move out of that position. I'll do the same thing on this one here too. So guys, this is really, I'm just kind of giving you some tips on the way I've learned to work with it. There's not only one way. You can use other types of joints. You can have other ways to set up your vise as well. And I'm just showing you some tips and things that I've learned as we go along with our, with this webinar. So now I have that locked in space. I have it 3 inches on the open, and now I'm going to start to capture my design history. So now that I set this up, I'm going to right-click on the actual main part itself. I'm going to go down and say Capture Design History. And now it captured the design history, and it also keeps down here the history of what I've done so far. When I've grounded those parts, when I've moved them, and I created those joints, they're all in the history in this group right here. Okay, so now what I'm going to do is I'm going to save it to that folder. I'm just going to go up to Save. It already knows the name. I'm going to do a Save As, actually. I'm going to go up to File, Save As, and I'm going to call it my, my Chick Vise template. Because now I can use it over and over. So I can use this template over and over again. I can open it up and then bring in a new part each time and make a new soft jaw out of it. So this is like a template of what I have sitting on the machine. And it's a really powerful way to use this. It's a powerful CAD system. You might as well use it to its ability. So you might as well mimic what you have going on in the actual machine. And the closer you can mimic what's in the machine, the more accurate your programming is going to be. Okay, so let's create a quick part. Now I have a pencil sketch or let's say a napkin sketch of that sprocket, the actual hub of the sprocket that I'm going to make. So I'm going to go through and draw that up with you guys real quick. So I'm going to go up to New Design. I still have my template in the background there. I'm going to expand down so I can see my origin. So I'm going to draw, it's going to be a revolved part around the center. So I'm going to draw on the YZ plane. I'm going to create a sketch here. It's going to start drawing some lines that kind of represent the shape. So I can see my number line here, and I can see the dimensions, and I can plug in the dimensions directly. But what I'm going to do is I'm just going to kind of draw what I have on the sketch here real quick. So it's about 6 inches in diameter, so I'm going to make it about 3 inches here. And I'm kind of like just like freehand drawing it as I go. This is actually going to be a part that looks like this. And when I snap to the origin, it snapped a line here, or it snapped a constraint that keeps it parallel along with that X-plane. Okay, so now I have this region I'm going to work with. So I'm going to hit D for dimension, and I'm going to start to dimension my way around here. So this is going to be 3/4 of an inch. This is going to be 3 inches. This is going to be 1/4. There we go. This is going to be, let's see, 3/16. And this up here is going to be 5/16. So we're going to go. So now we have a constrained sketch. All my lines are now black. So now I want to revolve this around the center Z. So I'm going to go up to Create. I'm going to create a revolve. I'm going to choose this this region. And for my center axis, it's going to be the Z axis. And now I have this revolved body. So I made a quick revolve body. That's going to represent the base of the part. In fact, this is going to be the simplified version of my part because I'm going to add some features in here. So what I want to do is I want to capture that simplified version so I can use it when I'm setting up a soft jaw. So I'm going to go into the bodies here. I'm going to right-click on this body and copy it. Right-click on the folder of bodies, and I'm going to paste, and now I have a duplicate of the same body in the same position. What I'm going to do is I'm going to soft click. I'm going to call this one simplified. You can also, at this point, create a stock body, one that represents your stock if you're going to be a little oversized. For this webinar, I'm going to keep it as if this is my stock size, the overall width, as if it's already been turned down. But if you do, you can create an oversized stock part right here. Simply sketch it up, or you can expand this body out, make another copy, and then you can push-pull it and make it bigger. In fact, my simplified part, underneath of here, I'm going to actually do an extrude real quick, and I'm going to pull this down, and I'm going to make it a tenth bigger, 100 thousandths bigger. Okay? So that's going to represent, when I flip it over, how much I'm going to remove off the part. So you can see, as I look at that body, where's my other body? Oh, let me undo. You know what I did? I think I joined it. So I'm going to do this. Instead of doing an extrude, I'm going to modify. I'm going to hide this body, and I'm going to modify my simplified body and move it 100 thousandths down. So the last time I did that, when I did extrude, I joined it, and it joined all my bodies together. So you kind of have to be careful when you do that. So now I have a body that represents what the part's going to be, and I have a simplified body that's extended 100 thousandths lower. So I'm going to hide the simplified one and keep the regular main body on. And I also have that sketch that I can always go back to and edit that sketch. Okay, so now I want to draw the features that are going to be on top, which is going to be the fingers or the spokes, if you will, of the hub. So I'm going to go in and start a sketch on this plane, right, my XY plane. Okay, I'm going to create a sketch. I'm going to hit C for circle, and I'm going to add some features in here, some circular features. So I'm plugging in the dimensions I have on my napkin sketch here. And I want to get a center line on here, so I'm just going to hit L for line and grab a quick center line. I want that line, I'm going to hit escape, I want that line to be construction, so I'm going to select it, and up here on my sketch palette I can change it to construction. Now I'm going to add the features for the end of the fingers. So I'm going to add a circle like this. Actually, I wanted to give it a dimension, so I'm going to undo real quick. Let's do it this way. Circle, I'll do it this way, 0.75, it's going to be 3/4. And I'm going to do another circle, that's going to be a 1/2 inch. And they're going to do one more circle, that's going to be a 1/4 inch for my through hole. Really simple. Now I'd like to have this point on the construction line and this edge to be concentric. So I just hold Control and select those two. I'm going to choose coincident, and now I have them to be coincident. So I'm going to draw one of the ribs of the fingers here. I'm just going to hit a line for drawing. A line. Oh, let me get out of that. Here we go. So I'm just going to kind of grab a line off of here and then just attach it to here. I didn't add any constraints yet. I'm just kind of selecting. Now if I move, you can start to see where it wants to create a parallel constraint. So I'm going to let it create the parallel constraint, so when one moves or one's angled, the other angle will follow with it. And now I'm going to add some additional constraints, which I'm going to use tangent from here to here, and the same thing from here to here. So now I have tangency, and I want to lock them down. I want to make them constrained, so I'm going to add a dimension for angle. And that's going to be 3.5 inches. Sorry, 3.5 degrees. 3.5 degrees there. And one more feature I want to add in here is an arc in here. Now I could do a fillet, but it's easier for me just to put an arc, a 3-point arc, right at the end point of where that line attaches there. I want to be able to start it there, and I want to grab it to that, coincident to that line there. Now I want to make some tangency there, so I'm going to go up to tangent. I'll make this tangent with that, and this tangent with this line. So now it's going to take on whatever that dimension is going to be. That's an important piece on the next step I'm going to show you. So let me mirror this. So I'm going to go up to Sketch. I can actually grab a hold of these features that I want to mirror first. I just started a box from left to right, grabbed all the features including the constraints, and now I'm going to go up to Sketch. We're going to go down to Mirror, and it's asking me what do I want to mirror about because it already grabbed those elements. I want to mirror this middle line, and OK. And now I have these features and regions that you can see I can work with. So I want to make a pattern of these going around, and now the actual hub that I'm making, it's a family part. So it could have 5 spokes, it could have 7 spokes. So I'd like to make that an intent in my design. So I'm going to choose to make a parameter. I'm going to call this parameter called count, because I can use this parameter throughout my design. I'm going to give it no units, and let's say we start with 5. Okay? So now I have a parameter, a user parameter called count. So now what I want to do is I want to pattern these features as sketch features. Let me grab them all because I want to grab this edge too. So I'm going to grab all those features and I'm going to pattern that around. So I'm going to go up to sketch, circular pattern. Where's my center point? It's there. By default it makes 3, but I want to change that quantity. I just start typing C and it remembered my count user parameter and it made it turn to 5. Okay. So now we have some features on here that I can start to put into this body. So I'm going to stop that sketch. I'm just going to go to modify. I'm going to grab this region right here. I'm going to stretch that region down, let's say, that's good, 700 thousandths. And when I enter it, my sketch goes away. So I just have to go over here and turn it back on and I can continue where I was. I'll do the same thing. I'm going to modify this region and I want to be able to get this feature. I'm going to bring it down as the boss and I'm going to make that one go down 40 thousandths. 40? Yeah, I'll make it go down 40 thousandths. I'm sorry, 400 thousandths. And now I want to have this counter sync in there as well. So I'm going to drag that down and we're going to go down 50, 60. Yeah, we'll go down 50 is fine. That's exactly what I have on my sketch. I'm going to say OK. And now I want to be able to get that quarter hole through. So you can do it this way or you can use a hole feature. I'm just going to grab it and modify and drag this through. And I can also tell it I want the distance to go all and it makes it finite through there. So now I could turn off this sketch and now I have these features. And I'd like to pattern those features. Now before I do, I want to put some fillets back in here so I can use a quarter or a half-inch bit in here. I'm going to use a quarter, so I'm going to make them an 1/8 inch. So I'm going to go up to modify. Oops. Let me cancel that for a second. I'm going to go to modify. I'm going to grab these edges right here into that edge, into this edge. I'm going to start to pull it. I'm going to make that an 1/8 of an inch. And now I have an 1/8 of an inch fillet going around. I want to pattern those features around. So one quick way to do it, I can grab all these features, but I want to do this at one time. So I'm going to grab this feature, I'm going to hold shift and grab the fillet feature. I'm going to right click and I'm going to add them to a group. So now it'll make it easier for me to grab them all at one time. So I don't have to window features, I already have them here. So now if I want to go and create, let's say we want to do a pattern, I'm going to do a circular pattern, I could just grab those features right here and now I can do select my axis, which is my z-axis. And again, I can say the quantity is going to be, if I start typing C, there's my count, user parameter, and I could say OK. And now I have those features on here. The cool thing about using that user parameter is now I can go up and I can modify that user parameter, and I can make that become, let's say, 6. And it updates the model right away. I can make that become 7. And it updates the model. So now I have my family of parts in one part. So I can make each of those in one part. Okay. Okay, so a couple more features I want to add. I want to add a hole in the center and I want to chamfer this edge right here. So I'm going to add the chamfer. I'm going to modify chamfer. Right here, I can pull it, press it. I want to make it an 1/8 of an inch, so I'm going to make that 0.125. And then I want to add a hole in the center for the hub. So I'm just going to say create, hole, choose that origin point. Selected my point, it's going to be a counterbore hole. My diameter of the hole is going to be 1 inch. My depth, I'm going to actually have this go all the way through. My distance here, so I'm going to make sure it goes all the way through. And now for my counterbore depth, I want that to be an 1/8 of an inch. And then for the diameter, it's 1 1/8 of an inch. Okay, so now I have that center hole. I can add some threads to it. I could just go to create, thread, select the hole. It recognizes the size, and I have choice if I want to have the fine threads or not. So I'm going to do that, and I can also choose if I want them modeled, if I'm actually going to put a bolt in there. If I want to download it from McMaster Car, I can actually put a bolt in there, or actually the rod, which I would check and make sure that the threads are correct. In this case, I'm going to keep it not modeled because it'll keep my model lighter, so it won't take up that much more memory. Okay, because I'm not really going to do any analysis on the threads at this point. So there we go. So there, I'm going to make this part. So there's our hub for our sprocket. And now I want to be able to bring that into the soft jaw, or bring it into the assembly to be able to make it a soft jaw. All right, so let me go up here and I'm going to save this. Go up to save. I'll save it as my hub. Actually, I can call it the sprocket hub. The sprocket hub, save it. Now, I want to be able to use that simplified body when I go to set it up inside of the soft jaw. Okay, so I'm going to save it as the simplified body. Now, if you had your stock body, you can always turn that on too, and then you'll have your body that represents the stock model when you bring it in. So I'm going to go back over to this chick vise, and now in my project, I can see I have that sprocket hub here. So now we're going to bring that into this assembly. Okay, so I'm going to right-click on the sprocket hub, and I'm going to say Insert into Current Design. And now you'll see that sprocket hub is now added to this current design. Since I set up my 0, I know where my 0 is, I know where the top of the part is, and I know where the center of the vise is, I could easily move this around. Now, this isn't the best way, I should say. It's good to be able to lock down, use some constraints. Let me close out my hub real quick. But I'm just going to move it around in position. For this webinar, I'm going to move it up a little bit, and I can know I'm leaving 20, or actually 200 thousandths on there. So I'm going to grab this and stretch it over. I'm going to eyeball it to the center. I can also plug in the exact number as long as I know where the center of the part is, and I know where the center of my soft jaw is. I can really position that exactly where it needs to go. So I'm able to get here pretty roughly. I'm going to say OK. And now I have that part in position, roughly placed where I want it. I can always go in here and add some assembly joins, and I can join it to the center. I can also have it go from the face down here. I probably would add some parallels in here, and I can also mate it to those parallels as well. But for the sake of time of our webinar, I'm going to leave it the way it is. Now, there's a couple ways you can do this to be able to get that diameter of the part into the soft jaws, or into the fixed jaw and the moving jaw. One of the ways we can do it is project sketches. So I can easily make a sketch on a plane, project that down, and cut away. Another quick way to do it is simply do what we used to call as a Boolean remove. In this case, I'm going to do it as a combine. So if I go to Modify, Combine, it's asking me what my target body is. I'm going to choose this fixed jaw. What's my tool body? It's going to be my model here. And it's saying I can join them or I can cut away. And when I do, I get a preview of what it's going to look like after it's cut away. Okay. And so now that's been cut away. I'm going to hold Alt so I can move it real quick out of position. And now I have that cut away matching the shape of the part. Now later on, we're going to find that if you have a stock that's oblong or even stock that's not quite right, it probably won't fit in there right. So we're going to add a sketch to add some relief in there. But right now, I'm going to leave it the way it is. I'll do that same process again. I'm going to go to Modify, Combine. My target body is going to be this moving jaw. My tool body is going to be this body, and it's already going to cut it away, and I can see where it's going to cut that away. Okay. So that takes care of the front end, and now I'd like to get my part back here, flip it over so I can get this face, so when I flip it over the other side, even though it's going to have the features, it's still going to fit in that concave shape, or actually that angled shape. So I'm going to go and make a duplicate of this same sprocket hub right here. So I'm going to right-click, copy, okay, and I'm going to right-click I'm going to actually do that right here in my main body here. I'm going to go to paste. And now I have a duplicate of that same part. And it brings me to that same move window again. So I can move this over into relative position. If I know exactly how far they are from center to center, I can easily move that to that position. And now I'm going to grab a hold of this rotator right here. I'm going to flip it 180 degrees. Now if you want to flip it along the X over the X, you can do that, but I flipped it over the Y. And now I want that to sit down there, 200 thousandths. Okay, and now I have that one in position. Okay, so let's take a look. I can turn these off. Actually, I didn't make them soft jaws yet, so let's go and do the same thing. I'm going to go up to Modify, and we're going to go down to Combine. My target body is going to be the fixed jaw. Tool body is this. I'm going to cut it away so you can see what it's going to look like. Okay, we'll do it one more time. I'm going to right-click and push up. This is my target body, my tool body. It's going to cut it away. Okay. So now, if I hide these, we can now see that we have what was left that matches the shape of the parts that we're working. Okay, guys. So let's go and set up some tool paths so we can cut out these features that we're trying to do in our soft jaw. Okay, so it looks like we have some time. Is there any questions so far about what I did in the walkthrough? I went through pretty quickly. Do you guys have any questions? Matt, is there any questions that that might be coming in the panel?
Wayne, Al here, and sorry I was a little late joining. You're doing a great job. Just one recommendation is a little bit of lag, so less use of the space mouse.
Ah, gotcha. Thanks, Al. So with this one, so it's possible. I'm going to come back in, I'm going to make a sketch, because often we like to sketch out here. I'm going to make a rectangle, because if the part is a little out of tolerance, you might not have it fit directly in there. So you can add a little bit of relief in there. We often like to add some relief that you're able to have the part fit a lot better. Now, this is just an example. Sometimes having a round edge on your soft jaw probably isn't the best way to keep it in, especially if you do have parts that might be off tolerance or your stock may be irregular. So even having some rectangle in here with a V groove might be a good way to do it. So if you watch those videos I had mentioned earlier, follow up with a lot of the work that Tim Paul was doing, Angelo, and CJ, and take a look at the way that they were handling and working with some of those parts. You'll see Mighty Bites come into play in the matching them up with your jaws as well. So there's a lot of different ways to hold the part in position. So I'm just kind of walking you through really basically how we would set that up and get some tool paths on it. So I'll add
there is a question in regards to tolerance from Nick. So often, and you're seeing a big gap on this chick vise, which is commonly what you do in a Kurt or something like that. Chick, sometimes you'd have a far less of a gap. But nonetheless, usually when you create a soft jaw, you clamp something in to create a space. One thing you definitely want to do is make sure you fit your part in the inside of the machine cavity before you loosen the jaw off and take that spacer out, because the jaw will shift a little bit side to side. So you want to definitely fit that part. You can use cutter compensation and comp it out, but just a little trick for that intolerance.
Thanks, Al. So as Al had mentioned, I could probably bring this a lot closer because I have all this room in that jaw to be able to hold it. And then a spacer would be in here. And as Al had said, you can put a smaller spacer and really make sure it fits in as you're working with those parts. So I'm going to add some tool paths just to show you what we would do to get some tool paths to cut those soft jaws really quickly. So I'm going to go and switch over to our CAM workspace. Okay, so we have our setups here. We're able to work through left to right to quickly and easily be able to set up tool paths. So the first thing I want to do in this setup now, right now we're working with those components that are already in this jaw here. So what I'd like to do, sometimes I'll just grab those bodies that I'm working with, and you'll see it'll extend across. So even though it's showing us as if we have stock here, I'm going to put some boundary in here to make sure it doesn't try to cut inside of those areas. So I'm just going to grab those three so I can set up all those toolpaths at the same time. Okay, we're also, we could set up, if we're using a box point, we can also change and use that same selected point, so we're always using that same point in the top center of the fixed jaw. All right, so I'm not going to add any additional stock. We're just going to leave it as it is here. Let me go and change this, no additional stock. Okay, so now what I want to do is I want to be able to get an adaptive in here. So
by the way, I'm glad you did that, Wayne. I so often see people zero out X, Y, top, side, side, bottom, and not know about just clicking no additional stock. Thank you for bringing that up.
Yeah, absolutely. It saves a lot of time and saves you a lot of grief on just being able to set that at zero additional. So, so I'm going to go up and grab a 3D adaptive. And so I'm going to rough these out with the 3D adaptive. So I'm going to grab a 1/2 inch mill. Let me grab a 1/2 inch flat that I think I have in here. If I don't, I can also filter down on the different types of tools that we're looking for. I can also filter by dimension. So if I'm looking for a 1/2 inch or a range, between 1/2 inch and 3/4, I can plug that in there. So I'm going to grab a 1/2 inch flat. I think I had one down here, but that's okay. We'll grab one out of the sample library. These are aluminum jaws, so I'm going to grab that. Now, one thing would be in your geometry, when you're setting up a toolpath, the question comes up is, what did you set as your boundary? Because if I let it go, it's going to fill in all that blank space. What do you set for your boundary? Now, I'd often just leave this as none. What I do want to do is I want to change all that stock boundary up top. I'm going to specifically select this as my stock boundary, these edges right here. I could do the same thing on here as well, because I'm just going to rough out that area. So a 3D adaptive is going to get into that area and work its way down. Okay, so for my heights, I can set an area where we need it, the bottom of the height to be, but I'm going to see if it's going to stay within that boundary. And I can also set up our passes, our optimal load to match the feeds and speeds of the tool, to match your load, how much you want to stay engaged, constantly engaged with the material. So for now, I'm going to leave that the way it is. I'm going to leave some stock on there. Probably don't want to leave it on the walls, but that's okay. We're going to leave some stock on there. We're going to come back and finish it up. By setting those stock boundaries, it'll keep the tool in those areas that I want to keep the tool. So it doesn't try to cut inside of that gap there. We told it specifically where we want that tool to stay. Okay, so I'm going to follow up. I want to be able to get all the horizontal areas, so I'm going to do a 3D horizontal. Okay, I can use the same tool, flat mill. I probably would use a bullnose mill to do the roughing, but we're going to use that same flat because that's what I have in my machine right now. So I'm going to use that same tool. We could do the same thing. Now, the one thing about a horizontal toolpath, it's going to find all of the places where it can go wherever there's a flat face. So it finds its own containment. So I'm going to leave that the way it is for now. I'm going to say OK and let it find all those places on the part that I left stock where it's all flat. You could set your step over. So we're cleaning up all those faces there. And now to get in this area right in here where we actually have that little tangent concave kind of shape right there from our part, I'm going to do a ramp. I like to do a 3D ramp. Sometimes you can do a radial, but in this case I'm going to do a 3D ramp to keep the tool engaged. And again, we can do the same thing. I'm going to switch out to a ball mill. So I'm going to change, and I'm going to filter down on ball mills. It's already filtering on my 1/2 inch, so I'm going to use my 1/2 inch ball. Okay, the same thing in here. I can tell it what silhouette we want to use, containment. So I can also do this. I can tell it on the model, what surfaces do I want to stay on? Okay, I'm going to select this surface and this surface. That's where I want to keep the tool engaged. Okay, let's see if how that looks. So sometimes you want to do that. Set up your toolpath, see what you get. Select an area or select the surfaces you want to keep the tool. let it go, see what you get. It's calculating for a while because I probably didn't set my boundary correct. Come on, Fusion.
It's fine. So yeah, there's a couple types of strategies you could use here. In this case, it's machining way down.
It is.
The other option I'm seeing comments on is you could just completely relieve that area and not even reference on that for your soft jaw.
That's true. That's true.
That would be a design decision, though.
Yeah, that's true. If I do set a boundary, I can set it this way, and therefore I'm going to keep the tool within those boundaries as well. That's one way to do it as well. So there is a lot of ways to approach it, a lot of different types of toolpath strategies. As Al had mentioned, we could always take that void out and leave that area so you're able to go in there and clamp down. So I was able to use the simplified version of the part to be able to get that area in here. So if we go back into the model, we go back into the model workspace, and I'm going to turn the part back on. So that's our simplified part there. Now, to get it today, right now, unless we bring that part directly in here, we can right-click and we can break the link. Then we're able to work with the sub-bodies and the components in the sketches. But since we're a linked part, they're controlled in the actual part itself. So for today, and I think our team's working on being able to make it so you can control some of the visibility of some of these aspects, they're going to switch it to the main body and turn it back to the simplified body. Or turn off the simplified body and have the main body and save it. Now if we go back, we can see an update has happened in our assembly. So I'm just going to go in here and choose to accept the update. Okay, and there's our part. So we have in the CAM, we can update and generate our toolpaths. We have the soft jaws ready, and we save this in a folder called soft jaws. And now I would start a new setup. I'll have to check out, there's my horizontal. I can start a new folder here, a new setup to start working on this part. I can choose the same. Now, I'm realizing we're really close to the time before we start getting into this part, but I can do my setup the same way. I can start setting up this part to be able to cut it out. I can change my stock to be that stock body that we create. I can also change my point, so I want to use that same selected point, so we're always using that same dowel pin hole or the type of pin hole that you have in the center of the fixed jaw. So you're always pointing back to that same center. It makes it easier to program. And again, if I wanted to use that simplified model as my stock, I can always go down here and choose from solid, expand this down, go into that body here, and I can use that simplified body to represent the stock that we're starting with. So if you have a body that you generate in the model, you can always select that right out of the browser tree right here to be able to set your stock that way. All right, so then I would start to machine the part. So that's one way to set up some soft jaws. So we're able to download Chick assembly or Chick model right from the website. We're able to upload it directly into our project. I was able to show you how to go into the model view to change this into an assembly where with joints where you can move the jaws back and forth. We're able to insert the simplified version of our part into here to be able to make the soft jaws from. Then we're able to go back and then change the part to be able to start to do the toolpaths on. And of course, the fun part I like is if I go back to the sprocket and I go to modify that parameter and say let's say we want 5 fingers on there, save the model. Now I have a completely different part family that I'm machining. And now if I go back into here, do the update, you'll see it'll switch, and then we'll have our toolpaths that'll update for the 5-finger version. So really quick.
Wayne, a couple tool library questions we should maybe hit on before the end of the webinar. Sure. The first one was from Tom. He's wondering about how to not have all the libraries show up. So if you can maybe just go into CAM,
Yeah,
go
sure.
to the library and show how you can choose what libraries are displayed.
Right up here, you can turn on and choose and turn off. So if, let's say we don't want the cloud library showing up or sample libraries, we can turn them off here, and we will be left with these libraries when we go back to our regular view. So you can easily...
So while you're here, the next question, it's ironic you turned off cloud libraries because the next question had to do with cloud libraries. So cloud libraries, when that's enabled, you'll have an asset library folder in your project, and then anybody that's part of the same hub will have access to that. So if you're on multiple computers, you'll have access to any libraries in there, and if you have multiple students, in the case Stephen for you, they'd have access. We just need to get set up as a team hub. I'll see if I can't find some good details on how a class would get set up that way.
Cool. So I hope that helps being able to show how we can turn off certain libraries in this view. And when you turn it off, go back to your main library, and now you'll be able to search and use only those specific libraries that you choose. Cool. All right, so that was the basics, being able to go in and get a vise and be able to download it, upload it, make a part, put it in there. Quick, it's a super fast way to be able to do it. There's a lot of ways to be able to skin that cat, to be able to set up your models, but hopefully this was helpful to give you a good start to see ways that we can work with inside of Fusion to be able to bring models from many different types to use them and quickly get your parts on your machine. All right, guys. Al, do you have anything that you'd like to add on working with SoftJaws?
No, I think you did a great job, and I think the biggest thing, whether it's SoftJaws or anything, you did a good job showing how you can use your model, use different solids of the model to be useful in designing your fixturing. It's often forgotten, and a lot of times people think of integrated CAD/CAM as simply a way of having access to the design, but designing your manufacturing process and using the CAD side to streamline that is a very important part of machining. So I think you did a great job highlighting that.
Thanks, Al. Cool, guys. Well, thanks. And next week, Matt Nichols is going to join us. He's going to show us how he programmed a really cool part on the Hasu MC750 at our demo days this year. So Matt's going to be with us. He's a Jedi Knight when it comes to programming and working with our CAD/CAM and integrated solutions. So it's going to be really good next week. Don't forget to vote for your classes at Autodesk University. So go to the Autodesk University website. Go into the classes and you can submit and make sure you vote for your favorite classes that you want to attend at Autodesk University. So with that, guys, thanks for joining us.
Bye. Good job, Wayne.
Thanks, Al.